Hello, everybody. Thank you for joining me today. I am Jennelle Crothers. I am a senior technical evangelist at Microsoft, and I've been with Microsoft for about 4 years. Prior to that, I was a systems administrator, predominantly Windows systems administrator for a couple small businesses, and I always find it interesting coming to events like this that have what I'm assuming is a large developer audience. Is everybody developer? Who's ops? Oh, come on. Audience participation is helpful. Ops. At any rate, I'm going to talk to you today about containers from an ops perspective, a little bit about how containers work in your business ecosystem, where they fit in the cloud, where they fit on-prem for you, and how all those things sort of tie together. So if you're a developer, maybe it will walk away with a little bit of understanding about how containers are going to be focused on from your operations team. And if you're in operations, hopefully this will give you a little bit of insight into how to bring containers to your business if you're not using them yet. But first, I want to get a couple things out of the way. 2 things, actually. I do work at Microsoft. We also love Linux. As I said, I've been with Microsoft for about 4 years now, and when I joined the company, it was right in the throes of our cultural change to be really embracing Linux and embracing open source. It's been really great to be part of that and to see that happen, because when I was a systems administrator, a lot of it was Microsoft's way or the highway. And not every tool in the Microsoft ecosystem is the tool that you need to use. So looking at how we're embracing Linux, we're embracing open source, really allows you to bring together the tools that you're using so that the people who are working for your company now don't have to relearn things immediately or don't have to relearn things unless it makes sense for your organization. The second thing I want to point out is we also really like Docker. We've done a lot of joint strategic investments with Docker to the point that the Docker engine is inside Windows Server so that you can run containers on Windows Server right out of the box. So we've put a lot of effort into that as well so that if you're a Docker user, you're using Docker client, you can use that to manage any container on any operating system from whatever device you're actually interested in using. You want to use a Windows client, great. You want to use a Mac or a Linux client, that's awesome as well. So with that as a bit of the backdrop, let's talk a little bit about containers and the cloud. This is day 2, day 3 for some of you here. There's been so much talk about how the cloud is driving a lot of these changes, driving DevOps, driving the ability for businesses to serve their customers faster with more iterations, releasing builds, time and time again during the day. So you can use containers, obviously, with the cloud. But you don't have to. You can also use containers if you're on-prem and you want to do more on-prem work and improve how you're doing business on-prem to release to your developers, to be handling your internal builds, or if you happen to work for a company that is still a little cloud shy. There's a lot of industries out there that are still not quite ready to move things to the cloud, not quite ready to make those changes, still looking at a lot of the security implications, a lot of the legal implications about where your data resides in different parts of the world. So you don't need to be moving to the cloud to take advantage of a container at this point. So you can start looking at that in your existing organization, in your existing data center, and take advantage of that. Still bring a lot of the DevOps to your organization without the cloud. Now, this is a slide I love as an ops person because it really explains the different cloud computing models and ultimately where containers fit in on this. If you are running things predominantly on site, and you can call it a private cloud if you want to, but a lot of organizations aren't really doing cloud delivery and self-service internally, but you can start bringing that to your end users if you start utilizing containers. But at any rate, when you're on-prem, you get to manage the whole stack. You're responsible for it, one way or the other, whether you like it or not, from storage all the way up to data and access. It's great for people who like to plug things in and manage every bit and piece of your ecosystem, and you may have been doing this for a pretty long time. But you're responsible for all of it, provisioning and managing it. When you start looking at infrastructure as a service and taking advantage of different cloud providers who have taken their on-premises, their on-premise data center and moved that to the cloud and are offering it to you, they're basically taking away, and you're giving up, the ability to manage the compute, the network, and the storage. You decide how much of it you actually want to use, but you're still responsible for that virtual machine all the way up to data and access. You're still looking at patching, you're still looking at maintaining, you're still making those decisions. Your developers are still deploying their software onto your servers that you're managing in the cloud. Maybe you don't want to do that. Maybe that's not the business you really want to be in. That's where platform as a service starts coming into play. You start utilizing a runtime provided by a vendor, and all you're doing is putting your applications and your data onto this platform. And finally, for many of us, depending on what your business is, your infrastructure, whether it's infrastructure as a service or on-prem or platform as a service, is probably somebody else's software as a service. And you might also be utilizing software as a service from a different vendor as part of your internal ecosystem. Everything with the application up to the application is managed by the vendor, and the only thing you're managing is what data you put on there and who's accessing it. So what does this actually have to do with containers? Well, with this background in mind, containers live here. They live in the operating system, the runtime, and the applications. That's what you're building with your container. And they live across all of these different ways of setting up your infrastructure at the same level. And that's where the beauty of containers actually starts to come into play. Because you can take a container that you built on-prem. You can move that container to infrastructure as a service. You can use that container to deliver software as a service for your customers. And that little sweet spot there in the interesting spot where it's orange and gray, platform as a service, and that container's little split, that's where things like microservices and Lambda and Azure Functions and things start to come into play. It's a very interesting place to be with microservices, but containers are a part of that as well. So back to containers your way. What ways exactly can we start doing this in our infrastructure? There's more than one. Building your own infrastructure on bare metal, on-prem, using an infrastructure as a service system, if you'd like. Looking at a container service. That's where you pick the orchestrator, but those servers, they're hosted by your cloud provider. Their infrastructure as a service is essentially your software as a service in this place. Or as part of a microservice fabric. Like I mentioned, Azure Service Fabric, AWS Lambda, Azure Functions. There's plenty of choices out there. So how do these containers help deployment? If you're coming from an operations standpoint, like I was, the goal in your job is to make sure that your developers are getting their application out there for your customer. If you're a developer, it's how do I iterate and test and QA and do this thing in a time frame that allows me to get my work done and to meet our business needs. So first, you can do everything locally. If you're an independent developer, you're working out of a coffee shop, you just want to try some things out, run them on your machine, and make sure stuff is working, you can run everything local. Your images are local to your machine, or you can pull them down from a public or private registry if you'd like, but the deployment is even to your local machine. Everything's right in that one box. As your container matures, you're ready to start sharing it with some others, you can start deploying this stuff to a server. Now, you can run Docker for Windows on your Mac or your PC, that local image, and you can go ahead and push that to something that's acting as a container host. Running Docker Engine, it could be a local server, it could be a local server running an infrastructure as a service, but one server. Well, that's all fine and dandy, but if I wanted to run my application on one machine, I'd have a monolith. I'd have a monolith at that point. So how do we go beyond this? We need to start scaling. We need to start making sure that our application is available. So you start scaling your own infrastructure. If you're doing this on-prem, now you're starting to cluster. Now you're starting to add an orchestrator, add some scheduling to your containers and things like that. If you're doing this on-prem, great. You've got the skill set in-house to manage clusters. Fabulous. If you're a startup, you might not have that skill set. Where do you get that infrastructure from? To scale that, you start looking potentially at a container service. Those clustered container hosts are given to you as a service. Orchestrators usually pre-installed. I know Azure, so Azure supports Docker Swarm, DCOS, Kubernetes. The scale sets are pre-configured. You decide how big you want those VMs to get, how many of them you want to start, what's gonna cause them to scale. All of these decisions you make, but you're not responsible for those actual servers, the actual VMs, the operating system that's on them. You just make some selections and kind of go from there. So some examples. You can take Linux containers on Linux VMs. That's a real common one these days, clustered or not. We've got Windows containers now. I'm going to show you a little bit about that to kind of set how that fits into the ecosystem, but you can run Windows containers on Windows Server. You can run containers on Windows 10 using Docker for Windows. A colleague of mine, Jessica, did a presentation yesterday. Bash on Windows allows you to start using Linux binaries on Windows. So now you can run containers that way on Windows 10, Linux or Windows. If you're looking for some more enterprise features and you're a big Docker user, Docker Datacenter is available from our marketplace. You can deploy that on infrastructure as a service inside your Azure subscription and run your containers that way. You can use Linux containers on Azure Container Services. I mentioned we've got Docker, DCOS, and Kubernetes. All of those will support Linux containers. If you want to do Windows containers, we support that with Kubernetes as the orchestrator right now. So there's a bunch of different ways you can sort of slice and dice containers to start using them in your infrastructure. One of the challenges with this is where to begin. If you have a monolith that you're trying to break up, it's not about just kind of jamming everything into a container. Containers really allow you to start picking out the portions of your application and the portions of your service that start making the most sense for containers. We're looking at the ability to scale. We're looking at the abilities to deploy quickly, to recreate things over and over again for test environments. That's where containers shine. So how do Windows containers work? I've talked to several people here at the conference who are like, oh yeah, we do Windows Stack and all this sort of stuff. What have we done to Windows? Now, anybody who's been doing Linux containers for a little while now knows that Linux comes with basically functionality built in, C groups, namespaces, that lend itself to that containerization that Docker wrapped their engine around to make work. Windows didn't work that way. So we had to do a lot of back-end retrofitting, shall we call it, to make the equivalent of C groups and namespaces so that the Docker engine can tie into those as well. But the reality is now they work just like Linux containers. When you look at a traditional virtual machine, you're virtualizing just the hardware. When you start looking at a container, you're actually virtualizing the next layer up. You're virtualizing the operating system. You're telling the application that, sure, it has an entire operating system itself. Go hog wild. You can do whatever you want to this operating system. You're not sharing any portion of it. But the reality is that it is actually sharing the kernel of the host machine underneath it, whether that's a VM or a physical piece of hardware. Windows Server Containers now does the same thing. We're virtualizing the operating system, not just the hardware, and letting that application think that it has the whole operating system to itself. You get the improvement of maximum speed, additional density. You don't have to wait for that whole operating system to start up. They're much faster to begin. But we added on an extra little kind of bonus that comes with our Hyper-V containers, which allows you to isolate them, plus get some of that performance. One of the security discussions around containers is the fact that it is a similar one to the ones that we had a decade ago, 15 years ago, when we started virtualizing hardware. What if my application breaks out of its container? Can it screw with its neighbors? Is it going to be a security issue? If I'm in an industry that has a lot of compliance, how do I ensure my customers that my containers, or at the time, my VMs are secure? So we have this additional feature called Hyper-V containers, which actually runs the container in its own isolated copy of the kernel. So it still boots up not as fast as a pure container itself, but also much faster than an entire VM. What's cool about this feature? It's a deployment choice, not a developer one. So as a developer, you don't have to decide, is this going to be isolated? Do I need to do additional special programming to support this sort of isolation? It becomes an operation decision as part of your business decisions. Do I deploy this on an isolated VM in an isolated mode, or I deploy it regular? It allows you to test and do your QA in an unisolated fashion and deploy your production in an isolated fashion if that ends up being part of your pipeline. So it's pretty cool that it's a deployment choice, not a development one. As an added sort of special kind of bonus, future versions of Windows Server are actually going to allow for side-by-side Linux and Windows containers because of Hyper-V isolation. Right now, if you are running a mixed environment, you want to deploy Windows containers and Linux containers, they have to be on different hosts because of the kernel underneath. But in the future, we'll be able to support all of that on one machine. Little explanation of how that works. If we're looking at a Windows machine, and we're looking at Windows containers, we've got our hypervisor on the bottom, of course, we've got our Windows kernel. You can actually see there's Docker Engine built right in there, running Windows Server containers. And if you did the isolated one, you get a special virtual machine running the Hyper-V container with its own copy of the kernel. Little caveat, the announcement that I just said was announced at LinuxCon about a month and a half ago. We haven't really got any real details about how the inside of this works, but here is my personal representation. I've got my disclaimer on the top that this is my personal explanation. What you're going to end up seeing is the Windows kernel and the Linux kernel in their own separate containers, side by side on that same hypervisor. So really pretty cool. We're looking at containers as a way to utilize hardware and infrastructure to the maximum capability, and this is another way to go ahead and do that. Instead of needing multiple machines to run Linux and Windows, you can now potentially put that all on one machine. So what does a container service do for me? You know, maybe I want to build my own stuff from scratch, but a container service is a great way to get started with containers if you don't have the infrastructure to support containers on-prem, or you don't have the skill set within your business to run and manage VMs. So obviously, Microsoft is not the only one. I certainly like Azure Container Services, and that's what I know. But AWS has theirs, Google Container Services. They've got their Google Container Engine. They're here. They've been doing talks. Great stuff. There's a lot of different services out there. So a container service is just going to make it simpler for you to create and configure and manage a cluster of these virtual machines. Because to allow for scalability, we need to be able to cluster these things in scale. And clusters are not inherently easy to manage. Our container service happens to leverage Docker to ensure that your applications are consistent and fully portable, and we support your choice of orchestrator. We also, you can also take a container service, and it's supported on Azure Stack. So if you want to build this type of infrastructure on-prem using on-prem hardware, Azure Stack allows you to do that too. It brings you sort of the Azure portal and manageability to on-prem. If you're a DCOS user, one of the cool things about that is jFrog, Artifactory Enterprise, happens to be just part of their ecosystem. You can go ahead and spin up a DCOS cluster in about 5 clicks. I'm going to show you actually how to do that a little bit. And another couple clicks, and you've got Artifactory Enterprise running, and you can bring that right into your pipeline that way. If you didn't catch Elizabeth Joseph's talk yesterday morning, you should wait for the video to come out. She works for DCOS, and she gave a great demo of Artifactory running on DCOS that I'm not going to try to recreate here for you today, because she did a great job. But I highly recommend going back and checking out that video when it comes out. When it comes to Docker Swarm, we support Docker Compose, Docker Swarm on the back end as well. That's going to give you native clustering for Docker, and it serves the standard API. And then finally, with Kubernetes, you can go ahead and take advantage of that as well. So you have a lot of choices when it comes to what you're going to do to orchestrate these containers. When containers are actually not small enough, we have there's two other things out there that you can look at. We happen to have Fabric Service. This allows you to do microservices and build applications in containers or as microservices, and allows you to orchestrate things beyond just containers. Random EXEs, a little bit of a Java app here. You can kind of containerize anything with it. And then finally, Azure Functions. Azure Functions, or if you're coming from the AWS side, Lambda, fits that sweet spot where you are bringing just the application part, the application code, to another container that's a platform as a service. The operating system and the runtime is provided to you, and your code goes in there as the last little bit of that container to run on a cloud provider. Really small composed parts, easy development, really easy to scale out, usually running on cron jobs or based on things getting dropped in a queue or something like that, and just running code when you need it. What's awesome from the operations side is we support PowerShell in this now. It's in preview, so you can actually start using a function like service to manage other operations type jobs as well. So far, all I've really talked about is where to run containers. Where do we get these containers? Or where do we put them if we're developing them from other people? That's where registries start coming into play. Docker has their hub and their store and their trusted registry and their Docker registry that you can take advantage of. Very popular. Place to put your containers and get them from now. We have a container registry in Microsoft and Azure as well. And this is where jFrog comes into play here too. Artifactory and Bintray fit right into this ability for you to manage your own registry with a different set of feature set, potentially a more robust feature set when it comes to authentication and management and things like that. So how does container management work with these registries? My previous slides all basically had you developing on your machine and pushing to the cloud. But the reality is when you're building a more robust pipeline and doing continuous integration and continuous development, it doesn't make sense for images to be coming from people's individual workstations or servers that you're managing on-prem. So what you end up putting in place is your code repo and your image repository. And you're probably already using some of these things, so that you're pushing to those places and then deploying to the cloud from those places. So there's where jFrog kind of fits right into there with that. And of course, it allows multiple developers to develop against the same code base, use the same images. When you're looking at bringing jFrog into here, you want to kind of note and look at the different feature sets. Artifactory is more of a development time side, a product where it has features that are going to make it much easier for you to manage binaries across your different developers and things like that. Bintray's more release time. You've got CDN and other features built in that are more related to distributing. So when you're starting to look at containers, you also sort of have to think of where do containers fit in your business model. Are you building a container so that you can quickly deploy infrastructure to provide a different service? Or is your container itself the end result that other people are using to potentially build their service and their products off of? And that's how you start trying to figure out, what am I going to use a container for? How do I break it up? How do I provide it? How do I distribute it? So I'm going to give you a little bit of tour here. I'm going to show you how to get started with Azure Container Service, a little bit about how to get started with Artifactory, and we'll go from there. So one of the quickest ways to get started with Artifactory, if you talk to all the fine folks here, is to just use their software as a service. They've released Artifactory quick and easy to deploy. Go to their website. Do you want it on AWS? Do you want it on Azure? Click, spin it up, put in a username and password, and you get all of that. That is their software as a service offering. The only thing that you need to do is put in your binaries and connect to it. This happens to be the version that my colleague was using for her demos. Really quick and easy. Put in your stuff and go. But what if you want to do a little bit more yourself? What if you don't want to use software as a service? What if you want to bring it in-house? What if you want to build it on-prem? What if you want to put it in your own subscription? Now, we have a couple different options for that. First, I'm going to show you, let's see. Yes. So we have a marketplace offering. If you want to look at it, you go into our marketplace, and you can search for Artifactory, and there'll be a couple versions. The versions that are up there are actually not the current versions because of the software as a service solution is really more robust. What a marketplace offering is doing for you is giving you a template that's going to build some of that infrastructure. But I'm going to use this as a little bit of a way to sort of set up what kind of infrastructure you're building in Azure as infrastructure as a service, and how that sort of works for operations here. So if we take a look at what we're given here, you can see that down here, I've got a couple resources. I've got a virtual machine. I've got a disk. I've got network interfaces. I've got an IP address, and I've got a virtual network. That's really not a lot of stuff. For Artifactory, it also needs database in the background. It needs some blob storage. It needs a whole bunch of sort of stuff. So their software as a service offering gives you that. You just don't see it. You're taking advantage of that because they've got that built into their infrastructure. But if you want to build it yourself, you can, except you're going to really need to provide a little bit more than what the marketplace offering happens to give you right now. But these are components that you're building in Azure. This is stuff that you'd build in your data center if you wanted to do it by hand. You'd need a network, you'd need disks, you'd need storage, you'd need VMs. This is where container services really sort of start to shine a little bit. So let me flip over to an actual container service here. So now I've gone ahead and spun up a DCOS container service. I was talking a little bit about how clustering is, there's a lot of moving parts with clustering. So let's take a look. This is a container service. The way that I would go ahead and do this, it's basically 5 clicks. I'll just give you a little show about how that works. I'm not going to spit up a whole new one to run, but you search for container services, you say I want to go ahead and create one, and you make a couple of really basic choices. You pick your orchestrator right from the top there. You pick your subscription, you create a resource group. You put a DNS name, you add in some credentials, your SSH public key, which I'm not going to do that. When you go to agent configuration, you get how many agents do you want? You want 3 agents? You want 5 agents? You want 1 agent? How do you want this to scale? How many masters you want? You hit go, you come back a couple minutes later, and you have all of the things that exist in my container service right now. So let's take a look at what we get here. We've got a virtual network. All these computers need to work on the back end. This is where I feel like containers get interesting to me because they're versions of operating system, isolated. They have their own networking. They think they have their own IP address. They're on a host that has a different IP address, which is on a cloud service that has, a different set of IP addresses. So the networking is really interesting to me. So you need a network for these hosts to run on. You end up, this is DCOS, so you get public and private agents. So there's a scale set for those. You have a bunch of storage accounts to spread disks around in. You need public IP addresses for all of this sort of stuff. You need some network security. You also need to have load balancers. And then there's the container service itself that is going to give you a DNS name for you to connect to. So all of this stuff is managed for you in a container service. Or you can build it yourself on your infrastructure as a service. Or you can build it yourself on-prem and be able to place that container anywhere on this. If I want to go ahead and get out of here. So that's kind of how you can get down in there. So when it comes to containers, your way, their way, kind of anyway here, containers kind of are the future at this point. They're kind of straddling this gap between developers of applications and the people that actually need to manage those applications and deploy that infrastructure. As an operation person, it frees up some time for me. It allows me to give developers an opportunity to deploy the parts of their application that they need for dev and for test. 15 years ago, There was lots of jokes, they're probably still going on now, that operations is usually the team of no. You know, you ask operations for something and it's, you know, no, we can't do it in the time frame you need it. We can't deploy it fast enough. We can't give you what you need. You can't have that. Containers is a way for you to say yes to your developers. Sure, you can spin up your development environment as long as you're, you know, developing in this particular, you know, as long as the end result is a container, you're going to use a container, great, we can let you do that. You can do that quickly. Your developers can have, you know, access to different areas of your online subscriptions. They can have access to resources on-prem. As long as they're doing it this one way, it allows them to have the freedom to spin up things. And when it comes to production, it allows you the ability to control where those containers go for production. Your containers are either the infrastructure you use to provide a service to somebody else, or they're the basis of somebody else's product, or both. So there's a lot of opportunity here. And when you're thinking about choosing tools related to containers, there's a couple things. You have to think about who the consumer of the container is. That's going to, you know, determine what kind of products you use to support containers. You know, if you're looking at jFrog, is it Artifactory? Is it Bintray? Is it, you know, other components of other third-party products that are in there? How will containers connect with your existing parts of your application and your infrastructure? As humans, we're very, very good at building monolithic applications. We've done it for decades. Nobody is asking you to take an application that is working for you right now and immediately shove it in a container. The worst part of infrastructure moving happens to be lift and shift. I'm going to just take what I have and I'm going to shove it in the internet. I'm going to shove it into the cloud. I'm going to shove it into a container. Usually not going to get the results you want. Great for disaster recovery, but you know, get something running, but usually not ideal. You want to be able to take the time to look at whatever application you're developing or deploying and pick the parts that make sense to be in a container. Do you need rapid deployment? Do you need the ability to scale on a dime? You know, what do you need, and what are you going to get from that? Do you need things that are immutable? One of the challenges with containers is, you know, they don't change. You deploy the same copy of something over and over again. How are you going to connect those containers back to your data sources? How are you going to manage the things that are actually, you know, actually have state that you need to track? So there's a lot of things that kind of go along with this. So you need to figure out, you know, where they fit into your ecosystem. How much infrastructure do you want to support? Do you want to do it on-prem? Do you want to build your own? Do you want to use a container service? Whose container service are you going to use? You know, what kind of orchestrator do you want to use? What are the goals of your business? They're different orchestrators, have different features. So these are all things to take into consideration. And like I said, don't feel like you have to put everything into a container to start. I mean, it is sort of the thing everybody's talking about, you know, get DevOps going, use containers as a way to do that. It is a great way to do it. But when it comes to DevOps is more about people and process and looking at pain points in your organization and figuring out how you can change things and how you can get teams to work better. Containers are not going to solve culture problems that you have in your business. Containers are not going to solve the fact that your developers and your operations folks, you know, are at odds with each other, if that's the case. But they are a way to bring some of those goals together. I want to encourage you to submit your feedback forms if you've got them. I also want to know if anybody has any questions. I'm happy to take some questions. I know I have a few minutes left. Everybody's good. You got one. Go ahead. Oh, hold on. Microphone. Yep. I remember. There we go. They'll make me repeat it otherwise. So.
Is there any functionality, or is there a way to run Docker commands within PowerShell? Or are there PowerShell modules available for Docker? Or is there a need?
It's kind of not really. We actually kind of went down that route. It was actually pretty interesting. When we first did Windows containers, you could manage containers with pure PowerShell, or you could manage containers with the Docker commands. And the PowerShell containers, you couldn't see the Docker containers that you deployed, and vice versa. We did some interesting things, and then we kind of abandoned it. We sort of said, you know what? Everybody's using Docker. We're going to standardize on Docker commands. So you can use PowerShell to pull scripts and to, you know, connect to Azure CLI and do these other things and call, you know, Docker commands, but you might as well kind of just stick with Docker at this point. Anything else? PowerShell's like super powerful, but sometimes the power is just being like, do this other thing. No, everybody else is good. Okay. Well, thank you for joining me. I realize I talk fast, so I got through my slides a little sooner than I expected. But I appreciate you spending the afternoon with me, and I know I'm also standing between you and some sort of snack. Hopefully it's ice cream again. That was pretty awesome yesterday. And enjoy the rest of the show. Oh, also, thank you very much. My blog is techbunny.com. I'm JKC137 on Twitter. And if you want to find me at Microsoft, it's first name dot last name at Microsoft. And I'm also here in the Bay Area. My colleague and I work out of Silicon Valley and San Francisco. So we are local to you if you are local as well. And feel free to reach out. Thank you.